is comparing linear functions to exponential functions. We will get into a little bit more of writing formulas for exponential models given a couple of data points. So a little bit different than what we were given last time. So here's what I want you to do to start us off. You have a table here. You see the x values, and notice that your x values are increasing by a common 5. Okay. The next row that you have are the values of your function f, and then the last row are the function values of function g. So the first thing that I want you to do, and I'll just give you a minute or two to do this, just jot down what you get. You don't have to write it all out. But what I want you to do is find the difference between the consecutive values of f of x. So for example, 45 minus 30 is 15. Okay, so you're finding the difference between all of your function values. So just kind of do it real quick, make a couple of notes about what you're getting for those values. What are you getting for all of your differences here? 15. So I have 1, 2, 3, 4, 5. Should be a difference of 15 between each of those successive values. Okay, I want you to now do the same thing for your consecutive values of g of x. So for instance, 1200 minus 1000 would be a difference of 200. Do the same thing, jot down the differences that you find. Alyssa, what did you get after the 200 difference? What did you get for the next differences here?
I got 240 and then 288, 345.6, and 414.7.
Okay, good. So what are we noticing here? First of all, let's go back to f of x. What are we seeing for the difference in the function values of f? What?
They increase at a constant rate for f of x.
Okay, so but what about the difference?
It's the same.
Yeah. Okay, so the difference between successive values of f of x are constant. Alyssa stated that a little bit differently. She said they're increasing by the same amount. Are we seeing that, however, with g of x? No. Okay. So let's say, but not for g of x. Okay, so based on that, what can you say about the type of function f is? The type of function f is. Amber, what do you think?
Linear.
Okay, so f of x is linear. G of x is not. And we'll talk about what type of function g of x is in just a moment. You may be able to guess based on what we did last time. But what?
Exponential.
Yeah, okay. So what I want you to do lastly is find the ratio of consecutive values of g of x. So not finding the difference here, I want you to find the ratio. For example, 1200 over 1000, you can divide that out to get its ratio. So take about 2 minutes to find all of the ratios of consecutive values. Rachel, what are you getting for your ratios here?
5 to 6.
Go ahead and state it as a decimal, that's fine.
0.83.
That's actually not what we should be getting.
2.
It should be 1.2. Did you put the bigger one on top? Okay, that's why. When you're calculating things like that, make sure you're going from like the second one back to the first one. But okay, so we should be getting that all of our ratios are 1.2. Okay, that's not just a coincidence. So based on this, we kind of already talked about the left-hand column here. Let's focus then on looking at these differences. So if your difference of consecutive values, let's say consecutive function values, are constant, then you could have a linear function. Like we saw with function f of x, the difference of our consecutive function values were constant. Just based on what we're given in the table, we would assume that's a linear function. We probably aren't given all of the function values. That's why we kind of put that could be. But just based on what we are given, we would assume that's a linear function. On the other hand, if the ratio of consecutive function values are constant, the function could be exponential. So you'll be asked questions like, is the function represented by the values in the table linear or exponential, and why? And then the other thing that you would be asked to do is to then actually write a formula to represent that function. So let's look at doing that. All right. All we need are 2 data points. Just like you need just 2 points to write the equation of a line, you just need 2 points to write the equation of an exponential function, okay? So if we are given 2 data points, we can fit a line or an exponential function to the 2 points. And we know how to do this for a line. We find the slope, and we probably will use point slope form, okay? The following example will show how we can fit both a linear model and an exponential model to the same data, okay? So the first part of this will feel like review because we've done this quite a bit. All right, at time t equals 0 years, so at the very beginning of time when we're in this situation, a species of turtles is released into a wetland. When t equals 4 years, a biologist estimates that there are 300 turtles in the wetland. 3 years later, the biologist estimates that there are 450 turtles. Let p represent the size of the turtle population in year t. So we need, based on just those 2 observations after, 4 years and then after another 3 years, both a linear model to represent that population growth and an exponential model to represent that population growth. So for part A, it says find a formula p equals f of t assuming linear growth. It's important that you really read carefully. Interpret the slope and the p-intercept of your formula in terms of the turtle population. So keep in mind, again, that we want a linear model. So p equals f of t. This is going to be in our essentially y equals mx plus b, but in this case, mt plus b form. They want us to use t instead of x. So we need 2 things. We need the slope and we need the y-intercept. Okay? Before we even do any of that, let's pull out from what we're given 2 ordered pairs. Okay? Jack, is that a hand up or is that a... What is 1 ordered pair that we could pull from that information? Jack? Right, and it's actually going to be time is first, so 4, 300. What's the second ordered pair that we can pull from that? Kinsey?
7 on the 450.
Why 7?
Because it says 3 years later and 4 plus 3 equals 7.
Right, okay, so just really pay attention to things like that. Okay, so we have our 2 ordered pairs. Let's go ahead. Find the slope of the line that goes through those points. So 450 minus 300 over 7 minus 4. should be getting that our slope is 50. And then I am going to use my point slope form with my slope that I just found in one of those points then to write my actual equation. Yeah.
When we got to 50, why don't you use the 7 minus 4 over, or like 50 over 3? Because 7 minus 4. When you're finding the slope.
This is 150 over 3.
No, 50. Wouldn't it be 50 over 3? Because you do the 7 minus 4.
But this is 150 on top.
Oh.
This is 150 over 3.
Okay.
It's okay. Okay, so using our slope and our point slope form, we have our equation, but we talked last time, if they are giving you variables to use, please be conscious of that and use our variables. So even though we used y and x here, let's translate this back into a function using variables that they would like us to use. So population equals f of t. This would be 50t plus 100. Now we need to think about what the slope and the p-intercept, which is like your y-intercept basically, your p-intercept would be 100, what those mean for this situation. So let's start with the slope. To me, this is a little bit easier. What does that 50 tell us, that slope?
This is how much the population increases every year.
Okay, so that 50 tells us that the turtle population grows by 50 each year. Good. Mia, what does that 100 tell us?
At 0 years, there were 100 turtles.
Okay, so it says at t equals 0 years, a species of turtles was released into a wetland. So that means that we released 100 turtles into the wetland. So again, this is our linear model. This is our linear model. Okay, what we need to do now, using these same two data points, 4,300 and 7,450, now we are going to fit an exponential model that uses those 2 points. This is not something that you have ever done before, unless maybe you did it in science, I don't know, okay? But at least in a math class, I don't think you've done this ever before. So if this is exponential, they're saying to use p equals g of t. We know that in general, our exponential functions are a, b to the t. That's what we looked at last time. In general, we want a, b to the t. So there are two things that we need to know to be able to write our function. We need to be able to find our value of a, which is our initial amount, and then we need to find our value of b, which is that growth factor, okay? So the first thing that we are going to do is not find A, but we are going to start off by finding our value of B. Think back to what I told Rachel earlier, that we want in our ratio for these successive values, we want the bigger one on top. So keep that in mind here. So I know, going to this exponential, that AB to the 7th, so meaning after year 7, how many turtles did I have? 450. Because I know that my ratio has to be the same, I'm going to say that AB to the 7th over AB, oops, that's not right, sorry. Not to the 3rd. I'm getting ahead of myself here. AB to the 4th, I know is how many turtles? 300. So I'm just using, again, those two data points that we're given. I know that B to the 7th times whatever that A is 400. B to the 4th times whatever that A is 300. Now comes some algebra skills. I can cancel out my A's on the left-hand side. And then I can simplify using my exponent rules. B to the 7th over B to the 4th. What does that simplify to? B to the 3rd, yeah. So B to the 3rd equals 450 over 300. Then I'm going to let my calculator do the rest of the work. I need to solve for B. So if I take the cube root of both sides, I would get my value of B. So what I would do is, you could do it a couple different ways, but there is a cube root button in your calculators. So cube root of 450 divided by 300. We'll go ahead and round to 3 decimal places. So my value of B I'm getting is 1.145. So there's the first piece of information that we need to be able to write this exponential function. All right. So I have B. The next thing that we need to do now is find the value of A. Find the value of A. I can use either one of these expressions. It does not matter which one I choose. So let's say I choose this top one. So I knew that AB to the 7th equals 450. Okay, that's something that we've stated already. A times B to the 7th equals 450. But now I actually know my value of B. So I'm going to plug that value of B in. So A times 1.145 to the 7th equals 450. And then I can solve that equation for A. So what I would do, again, I would let my calculator do the work here. To solve for A, I essentially divide both sides by 1.145 to the 7th. So that's what I'm going to put on my calculator. 450 divided by 1.145 to the 7th. And I'm getting that A is equal to 174. So I have both pieces of information here. Now I can actually write my, this is g of t, my function. G of t equals 174 times 1.145 to the t. So remember, A is your initial value, B is your growth factor. This is our exponential model here. So now, what do these two values mean? Mike, what does that 174 mean?
174 is like your y-intercept, so that'd be how many turtles you release in the y.
Okay, so in our exponential model, we started with 174 turtles. Or how many turtles we released. What does that 1.145 tell us? So from this, we can get the percent. It's growing. What is the percent? It's growing every year. Very good. So we're growing our population by 14.5% per year. Good. Okay, what questions? Are you overwhelmed at all? Sydney?
How did you get 14.5 from 1?
Okay, that's a good question. So remember last class, let's say we were given that the growth rate was 14.5% per year. Okay? To get that growth factor, to get that value of B, we took 100 plus 14.5. That was 114.5, and then we turned it into a decimal. Remember?
Yeah.
So basically, we're taking that and working backwards. So you can think about putting that back into a percent, taking out the 100. That would give you, okay? All right, last example. We won't have time for everything today, but I do want to go through this last example. You're basically going to do the same thing we just did. It's just not in any sort of like real world context. You're just given the 2 points to use to write the exponential function. I'm going to go ahead and work through this one with you since this is something that's brand new. I don't expect you after one example to have it down. Some of you might, but I don't expect that yet. So we have -1, comma 2.5, and I have 1, comma 1.6. So this means that AB to the -1 power equals what? 2.5 over AB to the first power equals the 1.6. So I use essentially the x value as the exponent, the y value is what it equals. All right, in this case, again, those a's cancel out. And then we need to simplify our exponents. So b to the -1, how do we simplify that? What happens there? How do you simplify a negative exponent, people? Move it to the bottom. So we would have 1 left on top over b squared equals that 2.5 over 1.6. And to me, that looks like a proportion. So we can cross multiply. And divide. And then take the square root of that ratio to get the value of b. So I end up doing the square root of 1.6 divided by 2.5. Oh, we can't see that. And I'm getting a very nice 0.8. A very nice 0.8. So our value of B is 0.8, but now we need our value of A. I would suggest that you not choose b to the negative first equals 2.5 just because that's a little bit messier using that negative exponent. So I would start with that I know that ab to the first equals 1.6. That power of 1 is just a little bit nicer to work with than a power of negative 1. And we just found that our value of b is 0.8, so plug that in. This one's actually a lot easier than the first one we did. And then just divide both sides by your 0.8 to get your value of A. So Haley, what's the function then? The function. I'll help you out.
Like explaining what each of them.
Nope. F of x equals, actually write the function.
F of x equals 2 0.8
To the what? Well, I said f of x.
Oh.
So you would use x, yeah. Yeah. Can I answer?